In this video, we're looking at equations of quadratic form. Let's look at example A. It says 2p to the fourth plus p to the second minus 1 is equal to 0. You'll notice that if that had been a p squared, and this had been just p to the 1, it would be perfectly quadratic. And you can also tell that p squared is exactly the square root of p to the fourth. So, in other words, if you square this middle term, you do indeed get that term on the left. All right, so it appears that this equation is basically of quadratic form. So once we know that it's quadratic form, we can apply something called u substitution, where basically you just let the letter u be equal to the middle term here being p squared. So p squared. And then if that's the case, then we can say that if you squared u, you would basically be squaring p squared, and that would be the same as p to the fourth, right? Because the 2 times the 2 here will give you 4. All right, so with that in mind, the new equation would then become 2. Now remember, p to the fourth is the same as u squared, so we're going to say 2u squared plus u minus 1 is equal to 0. Now this is a standard quadratic equation which can be solved either by using the quadratic formula or factoring. All right, let's see if it factors. 2 times 1 gives you 2, and are there factors of 2 that subtract to give you 1? I think there are, so we should be able to factor this. So we'll say 2u and u in the first positions, and then for the number 1, we just split it up as 1 and 1. Now the fact that the 1 is negative means we have to have a sign of each, and we want the larger product to end up being positive, so I'm going to put the plus here and the minus here. When I check this, it'll be minus 1u, and then we'll have positive 2u, and if you combine those two things together, you do indeed get the middle term of 1u, positive 1u that is. All right, so now we can set these factors equal to 0 because we have a product that's equal to 0, so we apply the 0 factor property. So 2u minus 1 is equal to 0, and u plus 1 is equal to 0. Solving this one, you'll get 2u is equal to positive 1, and then divide both sides by 2, and you ultimately get that u is equal to 1/2 for the first answer. And for the second one, you'll end up saying that if I bring this over, I'll have u is equal to negative 1. Okay, now with those two solutions, we have to remember that we aren't solving for u, we're trying to find what p is, right? So let's go back and back substitute now. So what I mean by that is we're going to say, well, if u is equal to 1/2, then I need to know that since u is p squared is equal to 1/2. And likewise, if u is equal to negative 1 over here, then I should be able to say that p squared is equal to negative 1, because remember, u and p squared are the same thing. And to solve for just p, I'm going to take the square root of both sides, right? So I'll have p is equal to plus or minus the square root of 1/2. And again, p is equal to plus or minus the square root of negative 1. Now the first answer would be, of course, negative square root of 1 over square root of 2. The second answer would be positive square root of 1 over square root of 2. And for the third answer, we're going to have minus I, and the fourth answer plus I, right? Because the square root of negative 1, remember, is I. All right, we're almost finished. There's just one thing that we need to do. These radicals here shouldn't be written this way, so we're going to kind of rewrite them a little bit. If we simplify this, it's going to be negative 1, right, because the square root of 1 is 1, divided by the square root of 2. But we don't like that, so we're going to rationalize the denominator, multiplying the top and bottom by the square root of 2. And this is going to end up giving us negative square roots of 2 over just 2. Remember, this will be the square root of 4, which again simplifies to the square root of 2. It'll be the same for the other one, except for the answer will be positive. So we'll end up having square root of 2 over 2 there, and then negative I and positive I. So we end up with 4 solutions for p. All right, let's continue with the next example, example B. All right, so this one's a little more complicated, but you can still see that it's basically quadratic form. Because if you were to take this middle term here and square it, you end up having that term there on the left, the leading term, 7w plus 5 squared. And then, of course, we have a constant at the end, so it seems to be in quadratic form. Let's go ahead and solve it then by using u substitution. So if we just let u be equal to the middle piece, 7w plus 5, then from there, we know that u squared would just be the square of 7w plus 5. So we'd square that. Okay, if that's the case, then we should be able to go ahead and substitute and say that u squared plus 2u minus 15 is equal to 0. That's a simple quadratic that we can solve. There are factors of 15 that subtract to give us 2, right? Namely 5 and 3. So we should be able to factor this. So let's go ahead and do that. So we'll have u plus and minus, and we'll do 5 and 3. All right, now we have a product, and that product is equal to 0. So we can apply the zero factor property. So we can separate these factors and set them equal to 0. All right, so if we move the 5 over, we get u is equal to -5. If we move the 3 over, we get that u is equal to 3. But don't forget that u is actually 7w plus 5, right? U over here is 7w plus 5, so we need to say 7w plus 5 is equal to -5, and 7w plus 5 is equal to 3. Then from there, we should be able to solve these linear equations. So we'll subtract 5 from both sides here, giving you 7w is equal to just -10, and then divide both sides by 7. You will get that w is equal to -10 over 7. We subtract 5 from both sides here. We'll get 7w is equal to -2, and then divide both sides by 7, and of course we get w is equal to -2 over 7. So we have two solutions to our equation in quadratic form. All right, let's do our last example, example C then. It's a little harder to see that it's in quadratic form, but it actually is, because if you were to let u be equal to, and then you were to square u, so square both sides, you'll end up with x minus 1 quantity squared, and that will end up being x to the -2 power. So you see that indeed this is in the form 2u squared minus 5u minus 3. So again, the same thing applies, just set this middle piece here to u, and then check to see if the equation ends up resulting in something that has a quadratic form. Okay, so we should be able to solve this equation by factoring it. Let's try to do that. We'll create two parentheses, set it equal to 0, and we'll try 2u and u, and then we'll try to place the factors of 3 in the right location. So I might do something like 3 here and 1 here. Now it's negative here on the right, which means we have a sign of each. So I might try negative and positive like that. Now let's check to see if that works. I'll have 1u, that seems to work. And then we have 2u times -3, or -6u. When I combine those together, I do indeed get -5u. Okay, so that's the proper factoring. So we factored it, and we have a product now that's equal to 0. So it's time to apply the zero factor property. So 2u plus 1 is equal to 0, and u minus 3 is equal to 0. So solving this one, we'll have 2u is equal to -1, and therefore u is equal to -1/2. And then finally we get that u is equal to 3. So remember, we're not solving for u though, we're trying to solve for x. So we need to back substitute, right? So going back to here where we said that u is equal to x to the -1 power, we're going to say x to the -1 power is actually equal to -1/2. And x to the -1 power is actually equal to 3. All right, so I can write this x to the -1 power as 1 over x to the 1 power. Remember, when you bring the x down below the fraction bar, the power changes signs, and then we'll have -1/2 on the right. We can now cross multiply, basically multiplying x here and 2 there. So we'll end up having 2 is equal to -x, or in other words, -2 is equal to x, by just dividing both sides by -1. All right, let's look at the other one. We can do the same thing. This is basically 3 over 1, and that's going to basically be 3 over 1 is equal to 1 over x. So we can cross multiply again. That would be the simplest way to solve this probably. So we have 1 is equal to 3x, and therefore x is equal to 1/3 by dividing both sides by 3. So our answers for problem C are -2 and 1/3.